Hey guys, here's your review sheet. As it turns out, I'm going to have a little bit of time here to knock it out for you. Remember, your test is right around the corner. We're going to go right through the top here, starting with number 1. I'm going to go straight across the top. I'm going to do 6 times 21, which is 126. I'm going to do a to the 4, negative 4 times a to the 5th. So I'm going to add those. Negative 4 plus 5 is 1. I got b squared, and I have c to the 5th. Now, because 3 plus 2 is 5. Across the bottom, 5 times 6 is 30. I'm going to have a to the 3rd, it looks like. And I'm going to have b to the negative 4th. And I'm going to have c squared. Alright? So basically I just multiplied it across the bottom and top. Now I'm going to reduce these. These are both divisible by 6. You can see them here. So I'm going to divide these both by 6. That's going to leave me with 21 over 5. Now, a is on top and bottom. A is larger on bottom. 3 minus 1 is 2. Okay, remember, you subtract exponents when you divide. I'm going to move b to the negative 4th to the top. Or I can think, hey, b squared is bigger, so b stays on top. And I can do 2 minus negative 4. 2 minus negative 4 is 2 plus 4, which is 6. And then I have c on top. 5 minus 2 is 3. There's number 1. Number 2, I'm going to do the same format. I'm going to go straight across the top, and we get 6. A, 3 plus negative 4 is negative 1. I'm going to have b to the negative 2nd, and I'm going to have c to the 9th. Over 21, a to the 3rd, b squared, and c to the 4th. Right, I'm going to try to reduce these. These are both divisible by 3, so this is going to be 2 over 7. I got a to the negative 1 going on bottom, so I go 3 plus 1 is 4. B squared is negative 2, puts it on bottom, so b is going to be larger on bottom. 2 plus 2 is 4. And then c to the 5th on top. There you go. Right, let's jump down to 3 and 4 here. 3, please write out a plus 2b 3 times. I'm going to FOIL the first two. So I'm going to get a squared plus 2ab plus 2ab plus 4b squared. I'm not going to do anything with this 2 plus a plus 2b here yet. I'm going to combine these. So I'm going to have 4ab plus 4b squared. Right? I'm going to multiply a into all 3 of these. So I'm going to have a to the 3rd plus 4a squared b plus 4ab squared. I'm now going to distribute in my second term, which is the 2. Okay, so I'm going to have plus 2a squared b plus 8b squared plus 8b cubed. And now to finish up, it's nothing but like terms. A cubed has no brackets. My a squared b's, those come together to make 6 of them. I have 6 a squared b's. I now have ab squareds. I have 12 of those. 4 plus 8. And then I finish up with 8b cubed. And there's my final. All right, I'm going to do the vertical format for 4. So to line up my like terms, I'm going to do the distributive of 2x in here to my trinomial in blue. So this will be 4x to the 3rd minus 4x squared plus 10x. I'm going to distribute in my negative 7 in red. So negative 7 times 2x is negative 14x squared plus 14x minus 35. Okay, I'm going to add these up vertically. 4x cubed minus 18x squared plus 24x minus 35. Good to go. And that's that. All right, factoring 5, 6, and 7. With factoring with 5, I recognize there's a GCF here of 2, and that's it. So that's going to leave me with 27 r to the 6th minus 64 e cubed. This is a perfect cube, perfect cube. Just keep that GCF out in front. So the cube root of this is 3r squared minus, this is going to be 4b. My signs would be opposite, which would be plus, and always plus on the end. So 3 times 1 is 27, 3 times 9, r squared times r to the 4th is r to the 6th. Going after this blank, 4 times what is 64? 4 times 16, b times b squared is b cubed. Get my middle, multiply these two. So that's 12 r squared b. Excuse me. Number 6, perfect cube, perfect cube. So I have a binomial times a trinomial, same, opposite, always plus. Cube root of this is 2x. Cube root of him is 5y to the 3rd. Right? Go after this first blank. 2 times 4 is 8, and x times x squared is 8 cubed. 5 times 25 is 125, and then y to the 3rd times y to the 6th is y to the 9th. 2 times 5, and I need x, y cubed. That's everything. Okay, so there's 5 and 6. They were both SOAP problems. Going down to the last one here. 4 terms. Grouping. Think of that as plus in the middle. So these two have a GCF of 3x squared. These be with x plus 4. These two have a GCF of negative 3. These be with x plus 4. So now I got x plus 4 ripped out. I now have 3x squared minus 3. I have a GCF here of 3. So if I pull 3 out of this, I get x squared minus 1. This I recognize as factual because it's a perfect square. Perfect square is separated by a minus. This will be my last step. Thank goodness, right? So x plus 1, x minus 1. There's your front. I'm going to go ahead and jump to the back here. Looks like we're solving. Okay. First one we'll do in blue. I'm going to set this equal to 0. So I have x to the 4th plus 6x squared minus 72. So when I factor this will be an x squared in front. This will be an x squared in front. I'm going to factor it like a regular trinomial. Plus minus is plus minus. Numbers that multiply to be 72. Too much. 2 times 36, 3 times 24. 4 does. 4 times 18. 5 no, 6 times 12, and 7 no, 8 times 9. Which two have a difference of 6? 12 and 6. I can set each one equal to 0. Plus or minus the square root of 6. Over here I get x squared equals minus 12. Plus or minus 2i root 3. This is 4 times 3, ladies and gentlemen. The square root of 4 is 2i. Alright, so there are your 4 solutions. 2 of them are real, these 2. These 2 are imaginary. Okay, over here. Set this equal to 0. I gotta move this over. Notice I'm writing the x cubed next, followed by my 16x squared minus 5x. So they're in standard form. I can pull a GCF of 2x out. It makes your life easier. That'll leave me with x to the 3rd minus 5x squared plus 8x minus 40. So 2x I can set equal to 0 and be finished with it. So x is 0. And I'm going to factor what's in here. So I'm going to do these two to these two. That has an x squared I'm pulling out. So that's x minus 5. This is going to be 8, which will leave you with x minus 5. So x minus 5 is my first. X squared plus 8 is my second. So x minus 5 equals 0. X is 5. X squared plus 8 is equal to 0. So x squared, horrible x squared, equals negative 8. So x is equal to plus or minus 2i square root of 2. start with 10. Again, set it equal to 0. Try to keep them in order. These have a GCF of x cubed, leaves me with x minus 1. GCF of 1. Oh my goodness. This is a 2. The x is gone. So x minus 2. Sorry. So the x minus 2's match up. This is x cubed plus 1. So x minus 2 equals 0. X is 2. X cubed is factorable. Plus 1. Cube root of this guy is x, cube root of this guy is 1. So same, opposite, always plus. This would have to be an x squared, this would have to be a 1. This has to be a 1x. This guy is simple. X is negative 1, so they're my two real solutions. This guy I have to do quadratic formula. So I got negative 1. Got negative 1 squared minus 4 times 1 times 1 over 2 times 1, 2x. When you go through here, this is 1 plus or minus, 1 minus 4 over 2. And what do we get here? Sorry, I'll have to erase this to make room for the next one. This is square root of negative 3 over 2. So your last one will be 5 root 3 over 2. So two answers here are imaginary. 1 and 1, those are your real solutions. So we gotta get rid of this little dot. So there's number 10. Careful, careful, careful with 10. Okay, the x cubed is huge. Going to 11. Okay, so this is going to be GCF of x. So that's going to leave me with 4x to the 4th minus 25. These are conjugates. This is 2x squared minus 5 and 2x squared plus 5. That equals 0, so x is 0. 2x squared equals positive 5. 2x squared equals negative 5. So x squared equals 5 over 2. X squared equals negative 5 over 2. Square root. Square root. So this is x plus or minus the square root of 5 over the square root of 2. Get the square root of 2 out of the bottom. So this is plus or minus the square root of 10 over 2. Over here, it's going to be basically the same idea. You get I root 5 over square root of 2. Multiply root 2 out of there. So this is the same thing, except it's going to have an I in front of the radical. I root 10 over 2. 4 answers, okay? Or, well, 2 answers are imaginary, 3 answers are real. So there's the rule of that. I'll get number 12 set up here. I'm going to pause it, and I'll get right back here. Okay, you can see I had it set up. Remember, the side is 3 times the height minus 6. 6 less than that. I'm going to have x be the height. The BB is the area for a square, because the base of the pyramid is a square. So that's side squared, which is 3x minus 6 squared. First order of business, I'm going to multiply 1/3 out of here by multiplying both sides by 3. I get 144 equals. Over here, I'm going to square this, because I only have so much time. That's 9x squared. Minus 18x minus 18x, which is 36x, plus 36 times x. So I'm going to set this equal to 0 all in one shot. I got 9x cubed minus 36x squared plus 36x minus 140. So I distribute him in, and I move him over. Okay, these are divisible by 9x squared, so this is going to leave me with x minus 4. These are divisible by 36. That's going to leave me with x minus 4. So I'm going to set x minus 4 equal to 0. X is 4. That's a good one. And I'm going to have to set 9x squared plus 36 equals 0. So 9x squared equals negative 36, which means how am I going to get an imaginary number? I divide 9 over. That's going to be negative 4. So this is plus or minus the square root of negative 4, which is 2i. I can't have a side length that's 2i. Okay, but I can have a side length that's 4. So that means my height is 4 meters tall. And there's